Tom and Dante here for Must Have Coffee, and this is the minimal increment presentation for the Clueless Game project. The main difference between the skeletal increment submission and the minimal increment submission is the incorporation of the graphics elements of the game. We will demo the game and share what we learned through the process. So let's begin. The Clueless Game UI was an interesting task to tackle. We looked at the 3x3 set of rooms separated by hallways as a 5x5 array. This would allow us to track movements around the board in this 5x5 array and to move game tokens to the appropriate grid ID location noted as numbers between 0 and 24. Here is a visualization of the 5x5 grid with grid IDs applied. Note that grid ID locations 6, 8, 16, and 18 are unreachable by players during gameplay. But using this approach was one of the more straightforward things we found through implementation. The graphics approach we chose was to leverage 2D sprites. Sprites were the foundation of 2D arcade games in the 1980s, including games found on the popular Atari 2600 game console. Sprites are individual objects composited together as frames, which when iterated over provide the effect of animation. Think of cartoon flipbooks. As you flip through the book, the individual drawings acquire a feeling of movement. This technique was originally developed at Texas Instruments. It was popular at the time due to the limited hardware available. The sprites could be loaded ahead of time during loading of the game to speed the graphics process. We chose sprites because 1. We were an undermanned team of 2 versus other teams of 4 in the class, and sprites would allow for decent quality graphics with a limited team. 2. Sprites should be straightforward to implement, as well as maintain going forward if this was a longer-lived project. We will share some thoughts on this later in the video. 3. The amount of time for the semester prevented us from using a more comprehensive game framework. In the .NET space, gaming frameworks include Monogame and Unity. However, we thought it would take too long to do what we needed to do with either of these frameworks. For the assets, we used Adobe Illustrator to create both the game board, game tokens, as well as the custom game welcome splash. These assets were exported as PNG files for use in the game. The assets are bundled with the source code and can be found in the assets directory in the root folder of the project. And here are the game tokens. For this increment, they are nothing but simple circles that are 144 by 144 pixels. They allowed us to test out the movement of players within the game. Later, these could be swapped out for more complex sprite animations if time allows. And here's the welcome splash. We just want to show you how the splash screen was completed as well. We used an open source Sprite Library for the project. The Sprite Library did provide an advantage. It allowed us to use 2D sprite graphics within a legacy Windows Form picture box. Using a sprite controller object, the controller allows for a setting of a background image, in this case the game board we created in Illustrator, as well as use of the individual sprites on top of that game board. Sprites are easily moved within the confines of the game board, abstracting away the complexity of initialization and graphics management. But here was the negative. The open source library had several bugs, which we wound up having to find and correct. Dante is now going to give us a demonstration of the game.
Hi, this is Dante with Must Have Coffee, and I'll be showing our minimal demo. So I'll start up the server and 3 clients. 2, 3. In the minimal, when all connected players push start, the game will start. Okay, so the game has started. And Miss Scarlet always goes first. That was in the rules. So she can move to the hall. And that position updated on all clients. She can make a suggestion. So let's try this. So the drop downs show all your available options for cards that have not been revealed yet. so somebody needs to reveal. So Mrs. White can reveal the library. So those were based on the cards in the player's hand. And we can make an accusation. It's too early in the game, so we'll skip that. Okay, so let's see. Let's move to the lounge. And try the candlestick. Okay. Yep. Let's reveal the billiard room. And skip. Okay, so player 2, Colonel Mustard, now should move to the kitchen. And let's try Mr. Green in the hall. We can reveal the hall. Okay. Rooms are getting narrowed down here, so let's skip again. Okay, it's back to Miss Scarlet. Let's move to the hall. And we'll do the dining room. Okay. And the dining room can be revealed. So it has to be one of these. Okay. Move to conservatory. Let's see. Reveal the wrench. All right. Think that we're gonna go out on a limb and try this out. Oh, we lost. Okay, so now you can observe until the end of the game. Okay, so Colonel Mustard will move. And I wasn't paying attention to when the winning cards were revealed. This one reveal. Oh, I guess it's not the conservatory. Okay, so let's try. Okay, so this is the winning combos, Miss Scarlet and the study with the knife. And Miss Scarlet won purely because she was the last one left that did not lose. So I hope you enjoyed our minimal demo. We're looking forward to finishing up our final touches and ironing everything out for the final. Thank you. For the client UI architecture, we decided to go with swappable panels, so we could use the advantage of the .NET Designer to make these UI panels in different pieces. So this is the top banner of the application, the player profile, and a title bar. And then depending on each of the game states, there's a different input panel that swaps out, so that's on the right side of the screen. So here's the accuse panel, the move panel, reveal, suggest, and waiting. And then in each of these panels, they're all completely self-contained and respond to server game messages about what's happened, and they keep track of whatever they need to keep track of within the class itself. And when the buttons are clicked, they run the appropriate code and send the appropriate messages back out that get propagated back up to the server, as well as other client classes. So beyond those individual smaller panels, the main application window itself contains different layouts. So this is the start layout, which shows the clue image, unless you start the game. And when you start the game, it swaps to the play layout. And then the play layout has that banner I was showing earlier. It has the game board. Down below is a log control panel that we'll be implementing for the final increment. And then on the right is where the input panel goes. So as each turn transition occurs, this panel 2 here is chooses one of the input panels that's appropriate to the game state to show. And then when the game ends, the end layout is swapped in. So that's how we manage the UI. Self-contained components, very visual, able to lay it out, and we don't need to muck around with UI code to dynamically swap and to dynamically create any UI or buttons or anything like that. Thanks.
Thanks, Dante, for giving us a demo of the game. To conclude the minimal increment video, we want to share some thoughts and learnings we had during this increment. We chose .NET Core to develop a great cross-platform experience. We actually achieved that with the server component, which is cross-platform and can run in Windows, Linux, or Mac OS. However, with the client, the latest .NET Core UI offerings were too green, and due to schedule, we needed to implement legacy .NET Framework Windows forms. This is a struggle that many software engineering teams encounter. Do they try something new? Or go with something battle-tested? Although many would consider Windows Forms a non-option due to its legacy status. With the legacy software, we encountered legacy problems. We had issues with high DPI awareness, where on my HD monitors, items were different than on Dante's lower resolution monitors. That was a struggle for us to get right and to correct. We used open source for the Sprites library and encountered what often happens with open source software, bugs. Although there are a lot of great production quality libraries for many tech stacks in the open source world, the library we chose wound up not being production ready and quite a few bugs needed to be fixed. One bug was an issue where the library was compatible with 4 main windows, but wasn't compatible with user controls embedded within a window. And of course, we were using user controls embedded within a window. So we did make some adjustments to that open source library. So our conclusions are, we had a great experience with the server technology chosen. That worked great. However, we would have chosen a different framework for graphics. Thanks for watching the minimal increment video, and we look forward to forthcoming target increment submission video as well. Thank you.